Hello everyone. Today we are going to discuss about the secant method using Python. My name is Kambal Chandu. So the abstract of the project is the secant method is a numerical optimization technique that approximates the derivative of a function to find its minimum or maximum. In this case, the method is applied to adjust the values of the components in an amplifier circuit such as resistors, capacitors and transistors to optimize its performance. The first step in implementing the secant method is to define the objective function, which is typically gain or bandwidth of the amplifier circuit. The next step is to choose two initial points for the method to start, which can be randomly selected or based on the prior knowledge of the circuit. The method then iteratively updates these points based on these function values at each point until a stopping criterion is met, such as reaching a desired level of accuracy or a maximum number of iterations. During each iteration, the secant method calculates a new point by approximating the derivative of a function using the function values at the previous 2 points. The new point is then used to update the search interval for the next iteration. The method continues until the desired level of accuracy is achieved. Overall, the secant method is a powerful optimization technique for amplifier circuits as it allows for the adjustment of component using the values to optimize the gain and bandwidth of the circuit. The implementation of a method can be done using the Python. Why optimizing the amplifier using the secant method is important. Optimizing an amplifier circuit using a secant method or any other optimization technique is important because it allows for the adjustment of a component values to improve the circuit's performance. Amplifiers are widely used in many applications such as audio systems, wireless communication systems, instrumentation, where the performance parameters such as gain, bandwidth and distortion can significantly affect the overall system's performance. The secant method is an effective optimization technique for the amplifier circuits because it is a numerical method that does not require the calculations of derivatives. This is particularly useful for the complex circuits where the objective function may not have an analytical derivative, where calculating the derivative may be too computationally expensive. In contrast to other numerical optimization methods such as gradient-based methods or evolutionary algorithms, the secant method has relatively simple implementation and converges quickly to the optimal solution. So this is the implementation of the optimization of an amplifier using the secant method in the Python. So here we are implementing the NumPy and Matplotlib libraries from the Python library set. So NumPy library is used for making a mathematical computation using the arrays, and Matplotlib is used to have a plots of the ordered pairs whichever we got from the implementations. So here we are defining the Planck's constant, and here is the mass of the particles and width of the box potential, and then we are defining the function that calculates the wave function at the edge of the box A, and the function that defines the potential energy of the box, and then we are initial guesses for the energy value levels, and then the tolerance and the maximum number of iterations has been initialized, and finally we are just printing the results here, and with the results whichever we have obtained we are plotting the graph using the Matplotlib library. So the problem implemented in the above Python code is to optimize the gain of an amplifier circuit using the secant method. The gain of an amplifier circuit is an important performance parameter that determines the amount by which the input signal is amplified. In the code, the objective function calculates the gain of an amplifier circuit based on the component values provided as an input. The secant method is then used to iteratively adjust the component values until the gain is optimized to a desired level of accuracy. The initial points for the secant method are randomly chosen in this example, but they can also be based on the prior knowledge of the circuit. So the optimization problem in this code is an example of a non-linear unconstrained optimization problem, where the objective function or the amplifier gain is a non-linear with respect to the input variables such as component values, and there are no explicit constraints on the input values. The secant method is a numerical optimization technique that can handle such problems without requiring the calculation of derivatives. So here this is the graph of the output which when we are implementing the Python function. So this is what we obtain here. So thank you everyone for